homework time. Yes, happy homework time is here once again. Let's jump right in. Jot our name down at the top of the paper. I will put my name and you put yours. All things being equal as it were. And for today's date, I will write today. You write the actual date where and when you are in this world. Lesson 37. There are 38 lessons in Module 3. We are at the end. And so we've been doing 2-digit by 2-digit multiplication with 4 partial products. Today we start to narrow that down to 2 partial products, which is a big step towards Lesson 38, which is not one to miss, because Lesson 38 is about all you get in using the standard algorithm to solve 2-digit by 2-digit multiplication. So yesterday's with the partial products, today with 2 partial products, and then the Lesson 38 homework coming up where you actually dive into the standard algorithm. That's about all you get in really learning this. There'll be some review throughout the year, but these are important lessons is what I'm saying, that you cannot miss these. These are not ones to fold away. So let's take a look. We are to solve 26 times 34 using 4 partial products, that's right here, and 2 partial products, that's over here. Remember to think in terms of units. And by in terms of units, they're saying ones, tens, hundreds, and such as you solve. So in other words, if there's a 3 in the tens place, its value is 30. Don't just treat it like a 3 because it's not a 3. Its value is 30. That's what they're saying there. So then we'll write an expression to find the area of each smaller rectangle in the area model. So in other words, in this area model there are 4 smaller rectangles. In this area model there are 2, and we'll write expressions for each of those. So let's take a look. So we're starting off here. Let's write all of these expressions first. We'll be doing 6 times 30 in this quadrant. Over here it's 6 times 4. And then 20 times 30, you see that? We've done this before, that's why I'm not really explaining every little bit. We did this on yesterday's, right? And then 20 times 4. And just to point out, look, you see that here, 6 times 4, 6 times 30. 20, it's a 2 in the tens place, its value is 20. 20 times 4, 20 times 30. And that's what we have listed below, same exact thing in the 4 partial products. So 6 ones times 4 ones is 24 ones. And I'm going to line up my place values relatively well anyway. 6 ones times 3 tens. You got that? Yeah, it's 18 tens, right? Also known as 180. 180. The other way of doing that, and that's what we're doing here, we're doing 6 times 30, is to do 6 times 3 times 10, 18 times 10, 180. Another way of thinking of it. 2 tens times 4 ones, that's right here, 20 times 4. When you look at it that way, it's 20 times 4, you could probably, that 80 just pops out at you. I hope so. Or you can skip count by 20s 4 times. That's not too hard. 20, 40, 60, 80. There we go. 2 tens times 3 tens. Now these are the ones that often trip up students. Because they'll express it as 6 tens. But you're doing tens times tens. So think of that in terms of, if we use the associative and distributive properties here, I'll just go ahead and do it. In fact, let's write it out. If we think of this as 2 times 3 times 10 times 10, you see where I get that from? 20 is 2 times 10, 30 is 3 times 10, and then distribute it. Associate it, 2 times 3 times 10 times 10. That's actually helpful because then that shows you that it's 6 times 100, which is 6 hundredths, not 60. And you always have to give it the common sense test. 20 times 30, could that be 60? No, if I give you $30 20 times, 30, 60, 90, oh, I'm already past 60, right? So 600 makes much more sense. And then when we add these up, and I apologize, but I am just plumb out of room. So can I squeeze it in there? Probably not. Can I scroll up? Let me see. All right, that gives me enough room right there. All right, so 4 with 0, 0, 0 is 4. 2 and 8 make 10. 8 more, 18. And watch your place value alignment here. Mine isn't perfect, but you know, it's working. 1 and 1 are 2. 2 and 6 are 8. 884 is what I get over there. Now we're going to fold those 4 partial products into 2 partial products as a big step towards a standard algorithm. Okay, so here we're doing what? 6 times 34. Yeah, there aren't a lot of pages or examples in tonight's homework, but you notice that there's a lot to each one, and that's the way it is, deal. And then here we have 20 times 34, right? Okay, now, a couple ways we can go about this. When you look at 6 times 34, you're not like, hey, the answer is boom, most likely. But what that is it's these two, isn't it? 6 times 4, 6 times 4, 6 times 30, 6 times 30. Ah, so can I look at 180 and 24 and add them in my head? Well, I can break it into little bits. 20 and 180, I see pretty easily, yeah, 200, and 4 more is 204. And there are other ways of doing this. And notice I'm lining up my place value, it's important. If you look at this and you're just like 34 times 6, the answer is I don't know. Then what you do is you write out 34 times 6 and you actually do this. And you can do it in partial products. 6 times 4 is 24. 6 times, don't say 3, 30 is 180. Oh, and those are the same numbers we have right there, aren't they? Oh, yes, it is. And you add them up, and yes, you get 204. And we could do the same with 20 times 34, which we can see, look, here it is. There's the 20 times 4 and the 20 times 30. And 80 and 600, I think we can add those pretty easily in our head, can we not? Yes. We can see quite easily that's going to be 680. And when we put these two together, 4 and 0 are 4, 0 and 8 are 8, 2 and 6 are 8. We get the same thing, of course, we got over here, as we should. The other way, of course, of doing this is to look at 20 times 34. Because the numbers are nice and small, you can think of this as 2 times 34 times 10. And I skipped a step there, but you see what I did was I decomposed 20 as 2 times 10, and then distributed and associated 2 times 34. Most likely you and I, because there's no regrouping there, both can take 2 times 34 and do that in our heads. Double 34. Double 3 is 6. Double 4 is 8. And say, okay, that's 68 times 10. And we're just riding a times 10 slide, right? All the way back to the beginning of the school year. And so that's 680. 680 is what we got here. 680 is what we got there. All right, so we did a very complete job. I applaud you. All right, let's go on. And our directions in number 2 are identical. Same kind of thing. The only difference here is that the numbers, the digits, are slightly larger. We have an 8 thrown in the mix here to make sure we can do it with bigger numbers. But still, we're dealing with 1s, 2s, and 4s as well, so we can handle this. Let's write out our expressions to find the area of each smaller area, each smaller rectangle in the area model. So this is 2 times 40. 2 times 40. This is 2 times 1. And here we have 80 times 40. And 80 times 1. Because what we're doing is 41 times 82. So look, 2 times 1, there it is, 2 times 1. 2 times 40, there it is, 2 times 40. 80 times 1, there it is, 80 times 40. 80 times 40. All right, so 2 1s times 1 1, that's 2 times 1, right? It's 2. Yep, we can handle that. 2 1s times 4 10s, well, that's here. 2 times 40, skip count by 40s twice, 40, 80, boom, there we go. Make sure you're thinking in terms of units, also aligning your place values correctly as you go. 8 10s times 1 1, well, that's 80 times 1, we can handle that, right? 80. No prob. Now 80 times 40, I'll just write it out. We're going to use the distributive and associative properties in one giant leap to say, hey, this is the same as 8 times 4 times 10 times 10, which is to help you. Remember, this is the one that most often we teachers see students getting incorrect because they'll write something wrong, like 320 here would be a common response, or a common mistake, I should say. So 8 times 4, yes, is 32. 10 times 10 is 100. That means 32 hundreds. 3200, 3,200, okay, which is not 320. So 3,200. When we add all four of these partial products up, we get 2 in the ones place. 16 tens, regrouping the 100 to add to this 200, so that's 300, and 3,000, 3,362. Now we come over here, doing it with just 2 partial products. Remember, what we're doing here, what you're supposed to be learning, is making this intermediate step towards a standard algorithm. That's what lesson 37 is all about. So it is 2 times 41, right? We see that. And then 80 times 41. Now, 2 times 41 is oh so simple. There's no regrouping. You just double 41, right, 82. And notice that it is this, 80 and 2, yes. 2 times 1, 2 times 40, 82. All right, and then when we look at 80 times 41, that seems difficult, but I'll show you a little way of thinking about it. If you can look at 80 times 40, break it into 2 steps here. 80 times 40 and say that's 32 hundredths, and one more 80. So I'm going to ignore the 1 at first. So I'm going to say 80 times 40 is 3,200, and one more 80, 3,280. 3,280, 3,280, which you also see right here, 3,280. And if you look at that and are stumpified, then you simply write out 41 times 80 and do the multiplication. All right, when we put these 2 partial products together, we find the same thing, of course. 2 and 0 are 2, 8 and 8 are 16. Regroup that 1, we have 3. And 3,362. Beauteous! Moving on. And number 3 is one giant leap for humankind, is it not? Now we are ditching, like a bad prom date, we are ditching the 4 partial products, leaving that behind as juvenilia and moving on to just the 2 partial products with an area model, but still, no more 4 partial products here. Which is kind of a relief, because then we only have to draw 1 area model. Okay, what we're doing is 52 times 26. So just for my own well-being, I'd like to write that out first. 52 times 26. We're not going to solve that just yet. I just wanted to get it down so I can look at it before drawing the area model. So the area model, let's deal with one thing at a time, make sure we understand what we're doing. Just to keep consistent with what we've done in the past, I'm going to put the smaller number on the length. So it's 26, so I'll break that down as 20 and 6. So I'm going to have, yes, that partition there, right? Before I even draw out the rest of the area model, which I'm going to do now. And then here, I'm just going to put, that's right, 52. I'm not going to decompose it as 50 and 2. That would be creating 4 partial products. So if you look back, this is how we did the other ones. So here we have 6 times 52. And here we have 20 times 52. And whatever we get for these are what we're going to put here for our 2 partial products. So let's do as they did for us in the previous ones and draw some lines here. Those are the 2 partial products we'll add together. So let's do 6 times 52 first. Now, look, you can break this down in your head, and I'm about to, and then we can write it out so you can actually see what we're doing. So you can do it either way. If you can handle doing it mentally, and that's just a matter of practice, then great. If you want to write it out, either check yourself, be safe, or that's the best way to do it, then do that. Here's how I would approach this. I'd actually do it backwards. I'd look at 6 times 50. Now I know 6 times 50 is 300. 6 times 2 is 12. 300, 12, 312. All right. But if you look at that and you can't do that quickly mentally, and I do want to point out that's just a matter of practice. That's all it is. It's not like, oh, I'll never be able to do it. It's just, have you practiced it? Like if you haven't practiced riding a bike, you're going to fall off that bike. Doesn't mean you'll never ride a bike, just means you need practice. So 6 times 2 is 12. 6 times 5 is 30. Plus 1 is 31. And there it is, 312. How long did that take? 8 seconds? Okay. So 312 is our first partial product, 6 times 52. When we look at 20 times 52, we can actually use our distributive and associative properties to rewrite this as 2 times 52 times 10. Because 52, actually, we can probably all double in our heads, can't we? 100, 50 doubled is 100, 2 doubled is 4, 104, 104, which we're multiplying by 10. And we know what happens when we ride the times 10 slide, right? Everything goes up one place, and then we have 0, 1. So it's 1,040, 1040, right? So that's our second one. And I'm not going to do it out for this one, but if you were totally stumpified by that, you'd go ahead and write 52 times 20 and do out the multiplication. So 2 plus 0 is 2, 1 and 4 make 5, 3 and 0 are 3, and then we have 1,000, so 1,352 on a very rough estimate, very rough. 50 times 30, rounding those to the nearest 10, 50 times 30 is 1,500. This is in the right neighborhood. That assures me that I did not make a power of 10 error and write 104 here. If I had mistakenly put 104 instead of 1,040, I would have ended up with what? 416 as an answer, and an estimate of 1,500 is way too far away. So you see how the estimates, just doing it quickly mentally, all that rounding and estimation we did, will help you ensure that you have a correct answer. We are moving and grooving. We just have number 4 left, although it has 4 parts to it. Let's take a look. Who needs an area model? Not us. We're going to solve these following examples using 2 partial products. We will simply visualize the area model to help you. And to visualize that, it's as simple as this. Watch. 3 times 68, that would be our top row. What's the value of this 2? 20 times 68, that would be the second row. 3 times 68, 20 times 68, okay? And that's exactly what we're going to write here. First, we're going to do 3 times 68, and then we'll do 20 times 68. Now, if you look at 3 times 68 and you're like, it's a little too much to do in my head, I don't have enough practice yet. All right, well, so let's write it out. 68 times 3. 3 times 8 is 24. 3 times 6 is 18. 18 plus 2 is 20. 204. That's simple. What'd that take us? 8.5 seconds maybe? So respect the place value here when I write 204. Align your place values. Now here doing 20 times 68, I can think that this, again, use those properties to say, well, this is 2 times 68 times 10, right? I'm decomposing the 20 as 2 times 10 and associating it with the 68. Now, doubling 68 in your head isn't quite as easy as some of the other numbers we've worked with, but you can do it. Again, my method is to do it backwards. I can double 60, 120. Remember that, 120. I can double 8, 16. Remember the 120? And now 16. 120 and 16 is 130 and 6 is 136. So 136 times 10. Ride that times 10 slide like we did way back when. Oh, those were the days. 1,360. Now, if 2 times 68 was a little much to do in your head, you couldn't hold on to those numbers and picture it, that's fine. You can just get some more practice in that. And in the meantime, you'd write out, and heck, let's do it. You'd write out 68 times 2, knowing that you still need to multiply by 10. This is 16. 8 times 2 is 16. 2 times 6 is 12, plus 1 is 13. 136, exactly what we got. So then here, for the second partial product, we have 1,360. When we put those two partial products together, 4 and 0 are 4, 0 and 6 are 6, 2 and 3 are 5, and 1 in the thousands place, 1,564. A quick rough estimate, 70 times 20. 70 times 20 is 1,400s. We got 1,564. Quick rough estimate says, hey, we're on the right track. Again, the common mistake here is that power of 10, writing 136 here, which would have ended you up with what? 340, which you'd know is way off. All right, let's take a look at 49 times 33. Those double digits there, actually, you'll see will help us. Visualizing the area model, that top row would be 3 times 49. The second row would be, good, you weren't fooled, 30. Yes, not 3, but 30. Its value is 30 times 49. So 3 times 49 and 30 times 49. Very good. And a rough estimate here, just to do it in before we start, this is pretty close to 50, and this is pretty close to 30. 50 times 30 is 1,500. So 1,500 is our rough estimate. When we do 3 times 49, I'm going to show you a little way of thinking about it here. If this confuses you, forget about it and come back to it some other day. 3 times 50 is easy, right? It's 150. And this is going to be 3 less than that. So 147. So the product here is 147. But we can do it out. 49 times 3. Watch the magic. 3 times 9 is 27. 3 times 4 is 12. Plus 2 is 147 there. Okay, so you see how we did that? So 3 times 50 would be 150, but this is going to be 3 less. Yeah, okay. Again, if that makes sense to you, run with it. If not, run away from it. And the same thing's going to happen here, but it's going to be 30 less. You'll see. So 49 times 30. Well, guess what? We already did. Remember I said the double digits are going to help us? We already did 3 times 49. So this is 3 times 49 times 10, right? And I'll write it out just so you don't think I've lost my mind, using the distributive and then the associative properties. Isn't it this? And we already know 3 times 49. We just did it. It's 147 times 10 now. So 1,470. 1,470. 1,470. Aligning place values the best I can. 7 and 0 make. 4 and 7 are 11. Regroup the 1. 1 and 1 are 2. Plus 4 is 6. And we have 1,000. If you remember back, our rough estimate was 1,500. So we know we'd done right. If we did 3 times 49 twice, we would have gone, what, 294, and said, okay, something's amiss here. Excellent. So we just have C and D to finish out tonight's homework time. Let's do it. And in these last two, aren't you happy to see they've taken the training wheels off? Here we go. We just have straight up 16 times 25, 54 times 71. And we'll do it with 2 partial products. Picture that area model. The first row would be 5 times 16. The second row would be, what's the value of this 2? 20, yes, 20 times 16. So that's, those are the 2 expressions we'll be solving for, 5 times 16. And then remember, this is 20. We have to pay attention to place value. 20 times 16. Well, now to do a 5, and I'll draw some lines here like they gave us before, make it easy for us to see what we're doing and keep our place values aligned. 5 times 16 is actually easier to do in your head than you might think by, as I've said, doing it backwards. 5 times 10 is 50. Hold on to that, 50. 5 times 6 is 30. 50 and 30, 50 and 30, 50 and 30 are 80. Yes, very good, 80. Now, 20 times 16 is also very simple to do in our heads because we're going to think of it as 2 times 16 times 10. And here, I'll write that out for you so you can see it. 2 times 16 times 10. I've skipped a step there, but you know what I did was decompose 20 as 2 times 10, distributed it, and then associated, use the associative property of multiplication, 2 times 16 times 10, because this is a fact you should memorize and just know. 2 times 16, doubling 16 is 32, times 10 is 320. So 0 and 0 make 0, 8 and 2 are 10, and 1 and 3 are 4. And a little side note, you could have done this whole thing quite easily in your head by saying, relating it to money. Now, if what I'm about to say doesn't make sense, just forget about it. But if it does, use it. Multiplying by 25s is pretty simple when you think of money, because there's 4 quarters in a dollar, right? 25 cents is a quarter. So 16 is 4 sets of 4. So it's $4, 400 cents. So to think of it that way, like doing something like even 24 times 25, which seems like you could race your friends, you know, what's 24 times 25? Well, that's 6 sets of 4. So it's $6, it's 600, 24 times 25. Pretty cool, huh? 50s are even easier that way. All right, so let's look at this one. Visualizing that area model, we would first row have 1 times 54. That's nice and easy. And then a little trickier is, what's the value of this 7? 70. Good. Not 7. It's in the tens place. 70 times 54. So those are the two expressions we'll be solving in our partial products. 1 times 54 and then 70, times 54. Not listening to myself. Bad teacher. Okay. So we'll have these two partial products we'll put together. 1 times 54, all right, we know that, 54, okay. Now it's 70 times 54, even breaking this down into 7 times 54 times 10, which we've been doing all along for many lessons now, is only so helpful. You're probably going to have to write out 54 times 7 in order to solve this. And of course you can just do 54 times 70 straight. But I like this way. So 7 times 4 is 28. 7 times 5 is 35. Plus 2 is 37. So 378, right, times 10. Okay, so it's going to be 10 times that. So 3,780. Excellent. And now we just add up these two partial products. 4 and 0 make 4. 8 and 5. Good, you know that. 13. 1 and 7 are 8. And 3 thousandths. Let's do a little checking ourselves. This rounds to 50. This rounds to 70. 50 times 70 is 5 times 7 times 10 times 10. Or 35 times 100. 35 hundredths. 35 hundredths is the right neighborhood. If we had done 378, we would have been in the 400 neighborhood. We've been way off. So everything looks good. And can you believe it? You did it. You've gone and done it again. Completed another homework time, so I will see you next time. It is once again homework time.